Okay, my name is Tristan Richmond. Here is my demo of Programming Assignment 3. So on the left we have JSON, and I will log into that right now. JSON, and the purpose of this demo, is going to serve as the server, and that means Volta will be our client. So let me log into Volta now, and I will just go ahead and do that. All right. So we're going to first figure out what the IP is for our server. I don't know exactly if it's going to be the same, but we can see that the IP that we want to be using is this one right here. So let's go ahead and get our C executable ready on the client. The name of the executable is client, and we have two arguments passed. The first one is the IP that I highlighted on the JSON server. So 130.191.166.3, and then the second argument is the port of the socket we want to use. So we're going to use 5024, and we're going to keep that because we want to run the server executable first before opening up the client version. So for the server, it has the executable, and then it has one argument, which is just the port. So again, 5024. So we start the server, and we'll see it creates a socket ID 3. On Volta, we're going to start it, and we see now that it made a connection with the client with this IP, which is different than the machine IP for JSON. This public IP for Volta is different because it's a different machine. So now it's prompting us to type a string. So we're going to just type test first. And we see that the string is received after it's typed, and then they reverse it, and it's sent back to the client over the socket, and this is that received message from the server. Now, the way I programmed it, you can have multiple messages sent as many times as you want, and then when you're done, you can just type tilde, or you can Control C to end the process entirely. So for the submission, it asks for my name and just a random phrase. So I'll say hello world and CompE-560. And you can see it was received on the server, and this is it reversed. Very hard to read, but it is reversed, and this is that same string being sent back over to the client, and it's displayed. Now let's go ahead and end it by putting a tilde, and you can see the tilde was received, which means that the client is disconnected or wants to disconnect, and it's all done and shutting down on both ends. All right, so let's go ahead and get into the questions. Let's go ahead and look at the code for each. So using Vim, we're going to look at the client code on the right, and using Vim, we're going to look at the server code on the left. All right, so here we are. We have our JSON with the server code. The server code initially looks at the arguments. I did a little error check where it only accepts two arguments, which is the name of the executable and then the socket port itself. And so it's checking, and if it's two arguments, then it enters the chunk of the code. Anything else, it just says a error saying too many or too few, and then it leaves and returns -1. So in the correct case where all the arguments are passed, we start off by creating a socket. Now this is the same on both sides, but we create a socket object, and that's just into the code. Then we go ahead and get some values for that socket object and the address struct to be ready, so that way we can bind the socket. Binding it just is reserving the space for the server to say, hey, this port right here with this information is going to be used for a socket. And then what we do is we listen, which is just checking, letting the program know that, hey, there's going to be a socket that is going to be looking for other sockets or a connection to its socket. So we just listen on that socket, on that port. Then After listening, we accept any connections that are given out by the clients. So the clients at this stage are trying to look for a server to accept them. So this client, or this server rather, since our listen only was looking for one client, is going to accept the first client it sees with the necessary port information. And in our case, that's our client on Volta. So it accepts that socket and then establishes a connection. Now there's a do while, which handles the whole loop aspect where you can have multiple messages passing, but it starts by receiving a message in a buffer from the other side of the socket, and it checks to see if that is that end message tilde to initiate the fact that the client's done and it's disconnected, or it just looks at the message and it reverses it down here in this while loop. First, it copies the contents of the buffer into a new buffer, and then it reverses it with a little swap algorithm, and then it prints it out locally before sending it over to the other side of the socket. So it sends it, and once it's sent, it waits until there's no more received messages. So it sends the socket, and then it goes back to the top. If there's another message to be received, then it receives it, and it continues this until the receiving is all finished, or rather, it loses connection completely. Then it just exits, and it says that we're going to close the sockets, so that way there's no sockets that are remained open. And that's the server code. The client code works pretty similarly, a little less steps. Starts off by creating a socket object right here. Creates the socket, and then it formats the address struct so that way it has the port and the IP all in the right format, and it just goes straight to the connecting phase for the client, where it's just trying to connect to any server to accept it as a socket. It then, once that connection is done, has another do while loop where it's going to type a message. It prompts the user on the client to type a message. If that message is a tilde, then it's just going to send one final goodbye to the server and then closes the socket by exiting the while. If it's not a tilde, then it sends the message over the socket to the server, and then it waits to receive another message back. That received message is the reversed version of the original string sent. So that's how we're able to send our string to the JSON server and then have it be sent back and receive it reverse. And it just does a while one. It continues to do that over and over until that tilde is seen or there's a control C that occurs. And then right after that while loop is exited, it goes ahead and shuts down the socket and closes the socket. The shutdown is just to give a nice farewell saying that no more messages are going to be sent, and then the close is the actual closing of the socket. And that is the client code. So going to the questions now, let's go ahead and start with number 7 of the questions, which is what are sockets and on which layers do they operate? So sockets are on the 4th layer of the TCP/IP network protocol or network layer model. Socket is a established point-to-point connection where the endpoint and start point is all determined off of the IP and the port combination, so that you have the source and the destination IPs and ports, and that combination of bytes to form that is the indicator for the socket itself, and that is a perfect tunnel, if you want to call it, or a pathway for messages to be sent to another device, whether it's locally or if it's over a network. It knows the source and the destination that it needs to send and receive bytes over. Moving on to number 8, the difference between TCP and UDP. So the main difference is TCP is more for acknowledgement-based sending and receiving. So with TCP, you establish a connection, and then you send data from one point. You send the data, and you wait for an acknowledgement saying that data was received before sending another bit of data. And when you do that, you have a connection that is secure, and you don't have to worry about packet loss so much. It's just you're sending data and you get an acknowledgement, and then you send data again and you get another acknowledgement, and you're guaranteeing that connection. On the other hand, UDP operates in a way where you don't need that acknowledgement, and one end of the socket is just sending over the data to a particular destination, and then it's done. So it just sends and then sends and then sends. It sends as much as it needs until it knows it's done itself without having to hear back from the endpoint of the socket. So YouTube in the case uses UDP, but in our project, this is all based off of TCP. Number 9, if you're at a range of a port in the code, I tested this out, so let's go ahead and exit both of these and we can test this. If you're too low, it won't accept the connection. So we'll go ahead and choose a port 1. We'll choose port 1 for each. So it creates a socket. However, the client cannot connect to that socket. And that is because it is not actually available for our messages to come in. It's not a forward port or a freed up port, one of those two cases. So in the case that we're on the upper limit, as long as we're within the maximum amount of sockets ID, then we can still send stuff. So let's choose an arbitrary large number. So before we were 5024, let's add 4 more zeros to it. And we'll see that it's still 1, 2, 3, 4. It's still going to create the socket, and we can still connect to it and send messages. Another message. I can't spell correctly, but this is okay. And it's still sending data back and forth, and we can still exit it, and that's fine. What wouldn't be fine, though, is if we breached the maximum amount of client connections to that server. So the maximum TCP connection is 65,535 according to Cisco, and that is the amount of connections one single client and server can have with each other. So it'd be that many in parallel just between these ports. The server could have that many on multiple different connections, multiple different clients, but for one client and server, the maximum is 65,535 ports for sockets. And that is the end of this demo and this video, and thank you for watching and listening. I appreciate it. Take care.